Alright guys, so in this video here we're going to introduce the basic concept of hypothesis testing. So the title for 8.1 is Basics of Hypothesis Testings. So hypothesis testings is another way of looking at this is this is just another type of test of significance. And in the next video we'll discuss this more. What does it mean for testing for significance? So that's another way most people know what is hypothesis testing in statistics. Is what we look for the evidence and the sample data. Is the sample data significance enough for us to reject or not reject the null hypothesis? So that's another way of looking at hypothesis testing. Let's start with something really basic. What does the word hypothesis mean, right? So usually what we first encounter this word in a science class. So in science class, what we know this word by is a claim or a premise on how the world usually works, right? So someone will make claims and about the world, how it works and stuff, but it's needed to be investigated. So a hypothesis is not an actual theory yet; it's just a claim, right? So, you gotta look at evidence to make sure that the hypothesis is indeed supported or not supported. In stats class, in what we learned in this class here, in statistics, okay, usually a hypothesis is a statement, or a claim. And that claim usually involve the numerical value of a population parameters, right? So it's almost the same thing as what you will consider hypothesis in a science class, but in statistics is more geared toward a claim or a statement that talk about the population mean, a standard deviation of variance, or the population proportion, and it's our job is to look at data or gather evidence in whether we want to support someone's claim or another hypothesis to present an example. So that's what this chapter is about. We actually gonna look at sample data and see if the sample data support the claim or not and it's pretty straightforward, but it's a little bit formal being introduced in this chapter. There's a lot of steps to go through and it can be very overwhelming. So the first definition we have here, just as we stated, in stats, a claim or statement about the numerical value of a population parameter such as mean, so mu, P or V. This is called a hypothesis. Okay, so that's what we refer to in a stats class is a statement, a sentence, or a claim. Someone making a claim, and somewhere there's a number, and that number is the number that a person claim what the population value should be around there. That is a hypothesis. Here's some example. Example 1, in a given 1 year period, 9.5% of the population. So right there's that numerical value by the population. 9.5% of the population, or about 18.8 million Americans suffer from a depressive illness. So we don't know what year this is, just say 1 year period. So the claim or the hypothesis here, this is referring to P, which is the population proportion Americans suffer from depressive illness, and in this article here say that P is around 9.5%, or P is equal to 0.095. Okay, so that itself is a statement or claim or a hypothesis. Let's look at the next one. In 1967, Americans ate 114 pounds of sugar and sweeteners a year per capita. In 2003, each person consumed about 142 pounds of sugar per year. So it's not as obvious in this problem, but what they're saying that on average in 2013, each person consumed about 142 pounds per year on average. So this is a claim regarding a mean, the mean pounds of sugar per person consumed per year is around 142 in the year of 2003, right? So this is another claim. This is another statement that taken from some article. The third example. Sometimes you see the example is not as obvious as it, doesn't really mention the number at all. It just kind of vaguely describe or kind of state it. They say that the majority of consumers are not comfortable with drone deliveries. That is the proportion. So they're saying that the proportion P, proportion of consumers not comfortable with drone deliveries is greater than 0.5. So you do have to simplify this a little further and make this so that it's become a mathematical statement, and that's what we need in this class, is translate all this word into a mathematical statement, and we can proceed with a formal procedure of hypothesis testing. So this saying that P itself, the claim say that the proportion, so will be P, proportion is greater than 0.5. Okay, so P stands for the proportion of consumers who are not comfortable. So they're saying that the percentage or the percentage of consumers who are not comfortable with drone deliveries is more than 50%. Okay, so that's another way to translate that mathematical statement of P greater than 0.5. Here's some more definition. There are two types of hypotheses in this class. Formally, we start out with an example that a person or a article making a statement and a claim, and then we follow by the null hypothesis and the alternative hypothesis. So there are two hypotheses in this lesson here. We have the null hypothesis described as or denote as H sub O, or sometimes H naught. This saying that this is a statement that the value of the population parameter is equal to the claim value. So we're going to start with the statement saying that, okay, suppose this is the claim value, let the null hypothesis be the claim value. And usually this here, this is the hypothesis to be tested. Usually we start with some sort of assumption. Suppose the null hypothesis equals the claim value, and then we can proceed forward and look at the distribution of whatever that parameter is, or that sample is. This statement here say otherwise we're working with more than one distribution. I'll come back to that statement. But the null is always denoted as H sub naught, and usually it's a statement that say, okay, suppose this is true. Let's look at the data or gather evidence, see if it's support or not. Then the alternative, so if we assume something with the null hypothesis and we gather evidence, and it turns out the evidence doesn't support the null hypothesis, then we go with the alternative hypothesis, different claim or different statement. So that's what the alternative hypothesis is saying, is by H sub 1 or H sub A, depends on the book. Okay, so this saying that this is a statement that the parameter has a value somehow differs from the null hypothesis, and usually the symbolic form is either greater than, less than, or not equal to. All right, so if we start with the assumption that, okay, suppose the null hypothesis is mu equal to this number or P equal to this number, and if our evidence doesn't support that, then we're going to go with not equal to that, greater than or less than, depends what the audience want or what we want to show. So those are the two important definition or two hypotheses in this lesson. This note here, I said that some of the claims can be the null hypothesis or the alternative hypothesis or neither. Okay, we'll come back to that in a second as we go through this example. Let's start with an example here. This is the same example up there. Okay, so we're just gonna extract this and kind of go over how do we write the claim from the example, and how do we write the null hypothesis and understand what each of these hypotheses is really saying. So the example is the majority of consumers are not comfortable with drone deliveries. That is, the proportion or the percentage of consumers not comfortable with drone deliveries is greater than 0.5 or greater than 50%. So from that article, from that statement, we extract the claim. So in symbolic form, the claim itself is P is greater than 0.5. So this here we say this is the symbolic form. Why? Because it is in numbers, in mathematical symbol. We can translate that saying that is saying that the proportion of consumers not comfortable with drone deliveries is more than 0.5. So we have the symbolic form, and then we have the wording, you know, the interpretation, or just how we just kind of write out the whole thing so that would make sense. Sometimes we do a lot of this, and it's, you know, we forget the importance of, okay, what is that statement saying? What does that p greater than 0.5 mean? So having the wording interpretation really help us, you know, understand what we write down here. Then from the null hypothesis, okay, so if someone claimed that p is greater than 0.5, when we do our investigation, we need a distribution to work with, to find the, you know, to look at the data evidence and see where that data evidence will, you know, closest to 0.5. So in this problem here, what we're going to do, if we were to test this claim, we would need to sample, let's say we look at a random sample of 100 consumers and ask them, and look at that p hat. Is that sample proportion closer to 50% or not? Or is it greater than, right? So we do need to, okay, so let me start with this here. So how do we show the claim is false? Okay, well, we look at sample data, and if that sample data is not close to 0.5, then, you know, in terms of the statement, so if the claim falls, then you know, we just need to look at sample data and then come with this here. Is p has to be, we can show that p has to be less than or equal to 0.5. Okay, if somehow we can get to that as our evidence to support that the proportion is much less than 0.5 or equal to 0.5, is not greater than 0.5, then we can show that the claim is not true there. But this statement here, this has, you know, infinite many possibilities, right? So, you know, we can have p equal to 0.5 or p less than 0.5, and p less than 0.5, you know, you can have so many possibilities of value less than 0.5. So in order for us to figure out which distribution to work with, we need to, you know, establish some sort of, you know, rules or standard here. So in order for us to show this statement is false, we just need to show one of these. It's either this is true or this is true. This has so many possibilities, so we're going to go with this assumption here. So we're going to say assume, so the null hypothesis, we're going to assume that, you know, so we're going to say h of o is denote the null hypothesis. Assume that p is equal to 0.5. Okay, and then we're going to test this, okay, whether our data support this or not support this, and we're going to go back to a claim and really, you know, make a conclusion about the claim there. So we need a single value. Why? Because this will have, you know, we can use, this allow us to use the distribution of p hat, okay. We're going to look at sample data, and then from there we look at, you know, where that sample proportion falls from the actual value p. Because the distribution of p hat, we can use this mu of p hat and sigma of p hat there. So that's come from the distribution of p hat. So the null hypothesis is always equal to the claim value, as we state in the definition. We just define that. The alternative hypothesis, okay, so after we look at that data, okay, so, you know, after we do the test, suppose, so after, you know, we test the null from the data, from using a sample data, maybe p hat, and the null is not supported from the data. Okay, then we go with the alternative hypothesis. Okay, and that alternative hypothesis, we're going to denote that as h sub 1. Okay, it, you know, somehow we get a sample data and it doesn't agree with what this assumption is, then we're going to go with the alternative, and the alternative is going to be the opposite of this statement. This statement, p equal to 0.5, include the less than 0.5 here. Okay, so we want to go with the opposite of that, the alternative hypothesis. We're gonna go with P being greater than 0.5, which in this case is the claim itself. So in this case here, this is same as the claim. Okay. So I probably would have over-explain myself a little bit in this video here. From this example, what I want you to get out of this is, how do we write the claim from the problem? How do we write the null hypothesis? And how do we write the alternative hypothesis? And sometimes one of these hypotheses will be the claim itself. And that's what we'll get to, is at the end of this process is we have to state whether we want to support the claim or not support the claim based on the evidence. The next video, I'm going to go over several examples how to construct these hypotheses from the problem, and how do we write the claim itself.